Arvind Kumar Chaudhary, Solution Architect, Cognizant Technology Ltd, USA. Arvind Kumar Chaudhary is a seasoned computer science professional with over 2 decades of experience in the healthcare and finance sectors. He has designed advanced algorithms to improve medical devices and laboratory research. He has worked with leading technology firms like Tata Consultancy Services and Cognizant and major pharmaceutical companies such as Merck and Organon. A senior member of IEEE, Arvind has published more than 10 research papers in reputed journals and conferences, including IEEE and Springer. His current focus is on applying computer science to drive innovations in healthcare.
Thank you, Arvind. Let me start presenting. Good morning, afternoon, everyone. Thank you for joining this session. Today, I will be presenting our research title, Machine Learning Approach for Early Diabetes Detection. This study was conducted with a focus on developing efficient, data-driven methods for early screening of diabetes, using machine learning, particularly based on the clinical symptoms. With the goal, with the global rise of the chronic condition like diabetes, we believe non-invasive, scalable solutions are needed more than ever. This work is being presented now in ICCCNet 2015 and addresses both the technical and public dimensions of early diseases predictions. Diabetes mellitus is a chronic and progressive metabolic disorder characterized by high blood sugar level due to the body's inability to produce or properly use insulin. Globally, more than 422 million people are living with diabetes, and this number is rising. Most concerning is that many remain undiagnosed until complication appears. Commonly, symptoms like frequent urination, excessive thirst, or blurred vision are often overlooked. Traditional diagnostic methods like fasting glucose or A1C testings are effective but may be expensive, time consuming, and unavailable in low resource settings. This creates a gap that machine learning can help fill, providing rapid, affordable, and scalable diagnostic support. Importance of early detection. Early detection is critical in managing diabetes effectively. If diagnosed early, patient can make timely changes like dietary adjustment, exercise, or medication to avoid complications such as kidney failure, blindness, and nerve damage. Additionally, early intervention reduces the burden on the healthcare system by preventing costly advanced stage treatment. In some cases, identifying the prediabetes can be can even lead to complete reversal through lifestyle intervention. The goal is not just detection, it's timely, actionable insight that empowers both patients and clinicals. Role of machine learning. So, how does machine learning fit into this? Machine learning techniques allow us to uncover pattern in clinical or symptom based data that may not be immediately obvious. They enable models to learn from previous patients' cases to make prediction on new unseen ones. We particularly focused on non-invasive data, symptoms that can be collected by questionnaire or basic clinical assessment. This approach reduces reliance on laboratory testing and makes the model applicable even in the rural or under equipped regions. The idea is not to replace doctor but to assist them by flagging high risk cases early for follow up testing. Our experimental datasets. We used a publicly available dataset from Kaggle with 520 patients record. Each record includes 16 binary features, yes or no, indicates of diabetes related symptoms. Example include polyuria, polydiabesia, sudden weight loss, visual blurring, and obesity. Binary encoding simplified our model training while still capturing clinically significant signals. This setup reflects a real world screening situations where detailed biochemical data may not be available. The result evaluation. To evaluate how well our model would generalize to new data, we used stratified sampling to split the dataset into training and testing subsets by 80% and 20% respectively. Stratification ensures that the proportion of diabetic and non-diabetic patients remain consistent across both subsets, which prevents bias. This is a key steps to maintain reliability of our evaluation metric, ensuring that good performance is not just due to chance or an imbalanced dataset. Here, I want to explain about how we evaluated our results. We evaluated model performance using standard classification metrics, accuracy to measure overall correctness, precision to access how many positive predictions were true, recall to check how many actual diabetic cases we detected, F1 score which balance both precision and recall. Additionally, we used barrier score and reliability curve to for confidence calibration, essentially checking whether the model prediction probability align with the real world outcomes. These metrics gives a well-rounded picture of models' predictive power and trustworthiness. Our machine learning models that we used, we trained the compared five traditional supervised learning models: logistic regression, support vector machine, a decision tree, random forest, and key nearest neighbor method. The performance metric table shows the performance of different model on our classification task using accuracy, precision, recall, and F1 scores. Among individual models, random forest performed the best with 88% accuracy. However, our assemble model outperformed all others, achieving 90% accuracy, 91% precision, 89% recall, and F1 score of zero point 0.09. This means our ensemble approach not only makes the most correct prediction overall, but also balance between identifying true cases and minimizing false positives, making it the most reliable choice for our application. Now, if I talk about my methodology, we started with the 520 patients, 200 had diabetes, 320 patients do not. Our model predicted 180 true positive, 20 false negative, 290 true negative, and 30 false positive. If you can see the metric and the formula and the calculation with the examples, you could see the accuracy was 90%. Precision was somewhere 86%, and the recall was 90%, and F1 score was 88%. The model predicted most of these correctly with a balanced trade-off between missed detection and the false alarm. By prioritizing both precision and recall, we ensure the model is both safe and sensitive. Now let's talk about the conclusion and the future work that can be taken ahead. Our framework demonstrates the feasibility of early symptoms-based diabetic detection using the machine learning. It is a lightweight, interpretable, and suitable for real-time application, especially in the low-resource setting. In the future, we can plan to enhance it by incorporating patient history, lifestyle data, and possibly wearable devices input. We also aim to deploy it as a screening tool for community clinic.
Oh, thank you all for listening me, and any questions can be reverted back to my email ID. Okay. over to you back.
Thank you, Mr. Arvind Kumar Chaudhary, for your impactful session. Your discussion on utilizing machine learning approaches for early diabetics detection highlighted the incredible potential of AI in advancing healthcare diagnostics. We truly value your contribution to ICCCNet 2025.